I'm going to go through a few z-score problems like the ones on the homework assignment. In each of the problems on this week's homework assignment, the first part says, is the sampling distribution at least roughly normal? When you're taking a random sample from the population and you're calculating the mean of the sampling distribution is at least roughly normal if the population is normal or the sample size is at least 30. At least one of the two things has to be true in order for the sampling distribution to be at least roughly normal. So first let's check if the population is normal. The question says the population is skewed, so this one doesn't check off. Now let's check the sample size. The person is randomly selecting 120 people from the population to survey, so the sample size is at least 30. This one does check off. If at least one of these two things checks off, the answer is yes. One or the other has to be true for the answer to be yes. Since the answer is yes, we can move on to the next part of the problem. Part B says, what is the probability that the mean credit score of the sample will be lower than 690? In part B, we have to calculate a z-score. Since we're dealing with the mean of a sample, we have to use this formula. You have to use the formula for the z-score of a sample mean. The formula says to subtract the sample mean, x bar, by the population mean, mu, and divide by the standard error, which is the population standard deviation, sigma, over the square root of the sample size, n. We're going to take the sample mean of 690 and plug it into the z-score formula and turn the sample mean into a z-score. So let's plug in everything we need. The sample mean that we're interested in is 690. That goes right here for sample mean. The mean credit score of the population is 700. The population standard deviation is 75.3. And the sample size is 120. The person's randomly selecting 120 people to survey. Let's start by finding the square root of 120. The square root of 20 is 10.95. Let's divide 75.3 by 10.95. It came out to 6.87. If we round that to two places, it's 6.88. we subtract on the top, it comes out to negative 10. It's negative 1.45. Negative 10 divided by 6.88 is negative 1.45. The next digit after the 5 is a 3, which means that it stays at 5. We don't round up to 46. And if I had left, I rounded this number to 6.88. If I had just left it at 6.87, like what the calculator showed, it would still come out to the same answer, I think, but I just rounded this up to be a little bit more exact. So now that we have our z-score, we can go to the z-table. This part is the row, negative 1.4. The column is 5, or 0.05, since it's at the hundredths place. The number in the table is 0.7305. And that's the answer to part B. When the question says, what's the probability of getting a sample mean lower than a certain number, the z-table gives you the answer, because the z-table always gives the probability lower than the value, or to the left of the value. We can change it into a percentage by multiplying by 100. This next part says to create a diagram. Since it's a z-table question, we're dealing with a normal distribution. We're finding the probability of getting a value in a certain area of a normal distribution. So let's make a curve of a normal distribution. When you have a normal distribution, the mean of the population is at the center. And the population mean has a z-score of 0. I'm sorry, that was 7. It's supposed to be 700. The population mean is 700. We found the probability that the sample mean would be lower than 690, so we need to mark 690 on the curve. and the z-score came out to negative 1.45. So we need to put that under the curve also. This z-score goes along with 690, so we'll put this z-score right below 690. We took the sample mean of 690 and turned it into the z-score of negative 1.49. So these two numbers go along with each other. And we found the probability that the sample mean would come out to a number lower than 690. So let's mark off this area. Let's shape this area right here. So the probability that the sample mean will fall in this area of the curve is 0.7305. And 73.05% of the possible samples have a sample mean in this area of the sampling distribution. This is another problem. It's another similar problem, like the one on your homework. We need to start by answering part A, just like we did last time. The population is skewed, so this doesn't check off, but the sample size is 120. So this part does check off, and the answer is yes. That means we can move to part B. This says what's the probability that the mean credit score of the sample is higher than 720, which means that we'll be doing one extra step. We'll get the z-score, we'll get the number from the z-table, and then we'll have to subtract that number from 1. We can use the same z formula. The sample mean goes in first. The population mean goes in second. The bottom is the population standard deviation divided by the square root of the sample size. Sample size is 120. Let's find the square root of 120. 720 minus 700 is positive 20. Now we just need to divide 20 by 6.88. Comes out to 2.91. We have to round the 0 up to a 1 because the third digit is a 6. If the third digit is 5 or higher, the second digit rounds up. So the z-score has to be rounded to 2 decimal places in order to use the z-table. Let's now go to the table. The row is 2.9, and the column is 0.01. The number in the table is 0.9778. But this actually isn't the answer we want. This number is the probability of the sample mean being lower than 720. To get the probability of the sample mean being higher than 120, you have to subtract 1 by this number. So this is the answer right here, 0.0222. To turn it to a percentage, we just multiply by 100. Now we can create a diagram. Just like before, it'll be a diagram of a normal distribution. The population mean is at the center. The population mean always has a z-score of 0. We found the probability above 720, so we need to mark off 720. (720) had a z-score of 2.91. And we found the probability that the sample mean would come out higher than 720, so we have to shade the area above 720. So the probability the sample mean will fall in this area is 0.022. for 0.222, and 2.22% of the possible samples have a sample mean in this area. Let's do one more question. In this question, the population has a normal distribution, which means that this checks off, and the answer is yes. We don't have to check the sample size. Sample size doesn't matter. This question says, what's the probability that the mean credit score of the sample will fall between 705 and 710? In this type of a question, we have to calculate the z-scores of both sample means. We have to calculate the z-score of 705 and the z-score of 710. we'll calculate both z-scores, and then we'll look up both z-scores at the same time. First we'll look up this z-score, and then we'll look up the second z-score. To get the probability between the two z-scores, we have to subtract the larger decimal by the smaller decimal. So it's going to, we have to subtract 0.7852 by 0.6517. the answer is 0.1335. And we can change it to a percentage by just multiplying. We need to put the population mean down here with a z-score of 0. And we need to mark off the two sample means, which were 705 and 710. And we need to put their z-scores down here. Try my best to put them under each other, but this is a little bit off. And we found the probability of getting a sample mean between 705 and 710. So we'll shade the area between those two numbers. And the probability that the sample mean will fall in this area is 0.1335 or 1355. And 13.35% of the possible samples are in this area.